Assalamualaikum warahmatullahi wabarakatuh to Dr. Nas and everyone. My name is Nawira Alia binti Badrul Hisham. Today, my friend Tengku Eza and I will present about Brunner, Emmett and Teller, also known as BET theory. Based on the previous lecture, we have understood that Langmuir isotherm is correspond to the monolayer adsorption. So based on the Langmuir isotherm, scientists named Brunner, Emmett and Teller have came out with a theory known as BET theory that studies multi-layer adsorption of the surface, specifically solid surface, whereby the gas molecules can have multi-layer on the surface. It occurs especially in physical adsorption. BET isotherm is used to explain the multi-layer adsorption, where the adsorption process can be described in terms of the attachment of molecules directly on solid surface and the attachment of molecules to sites already occupied by adsorbed molecule, forming the second layer.
BET isotherm describe the absorption as the ratio of the volume of gas that is absorbed to the volume that would produce a single layer. For BET theory, the temperature of the solid surface is kept constant or under thermal conditions, while the pressure of the absorbing gas is increased. So as the pressure increases, more and more molecules absorb on the surface. Thus, eventually, a thin layer will cover entire surface in monolayer, then becomes a multilayer. So as you can see in the picture here, the gray area represents the porous wall on solid surface. The monolayer molecules in dark red color, while the red molecules become the multilayer, indicate that more absorbed gas are absorbed to the surface. The build-up layers, as in the picture here, can continue until as the gas pressure approaches the vapor pressure of the gas. The absorption has reached the stage where the surface could be described as wet due to vapor condensations as the pressure increased. So the most common absorbate is used in BET theory is nitrogen, because nitrogen has strong interaction with most of the solid absorbents. So when the absorbate absorbed to the surface described as wet. It happened due to the condensations of the absorbate as the pressure increased.
Before we get to know about BET graph, I'm going to introduce you to BET equation first, which is important for graph interpretation. The equation for BET is like this, whereby Z is equals to P over 0, where P represents the partial pressure of the adsorbate, P0 represents the saturation vapor pressure of the adsorbate, V represents the volume of adsorbed vapor at standard temperature and pressure, Vm or Vmon represents the monolayer capacity at STP, and C is the BET constant. As you can see, this formula has been derived from the linear equation y equals to mx plus c. Therefore, the graph should have a straight line. A plot of z over v1 minus z against z will give a straight line with slope equals to c minus 1 over v mon times c, and the intercept is 1 over v mon times c. To make it clear, you can observe the equations below, where the value of v mon and c can be calculated from the graph slope and intercept. Vmon is used to determine the surface area of the adsorbent, while the value of C is an indication of the magnitude of the absorbent-absorbate interactions. In terms of applications, BET can be used in wide areas. For example, In food industry, BET has been used to determine the optimal moisture conditions for good storage stability, especially for dehydrated food products. Furthermore, many pharmaceutical powder blend ingredients, including the active pharmaceutical ingredients APIs, binders, lubricants, and excipients, are characterized by BET surface area to ensure optimal dissolution, cohesion, and bioavailability.